Well, what's up, amazing people? You're welcome once again to yet another video in this series of stoichiometry that we have been dealing with thus far. I'm super excited to be here with you. My name is David, and I'm an online chemistry tutor for high school kids. In this video, we're going to be learning about the mass to mass calculations in stoichiometry. So I'd like you to sit back, relax, and enjoy every bit of what I've got for you in this video. So let's see if we can learn a thing or two. At this point, we have learned a number of things in this series. We've learned how to calculate the number of moles from mass. We've learned how to calculate mass from moles. We've also learned how to use the mole ratios. Now we're going to be combining all three ideas in one. So how do we do that? Well, I'd like you to check out this example on the screen. Here is a balanced chemical equation, but I want you to notice something. The mole ratio is 1 for nitrogen, 3 for hydrogen, and 2 for ammonia. These are mole ratios, not mass ratios. In other words, the ratios are given in terms of the number of moles, not the amount of mass. Okay, the number of moles and not the amount of mass. So when we are dealing with mass to mass calculations, we would have to convert from the number of moles into the amount of mass. The equation simply does not say 28 grams of nitrogen. It doesn't say so. It doesn't say 28 grams of nitrogen reacts with 3 grams of hydrogen. No, no, no. It says 1 mole of nitrogen reacts with 3 moles of hydrogen. That's what it talks about. It talks in moles. So when we are dealing with mass to mass calculations, when we are dealing with mass to mass calculations, we have to do some conversions. We have to convert. We have to convert. So I'll be showing you how that can be applied in this type of stoichiometry scenario. So we have a number of steps that you must follow when you're dealing with mass to mass calculations or mass to mass questions. Step number one would be to convert the given mass into moles. Convert the given mass into moles. Step number two would be to use the mole ratio from the balanced equation. Step number three would be to find the moles of the substance required and then convert the answer back into mass. Don't get worried. We're going to handle some questions so you can see how that can be done. So let's get into the questions and see what we can do. So we have this question on the screen right now. All right. The question says calculate the mass of water produced from 4 grams of hydrogen. Step number one, convert the mass into number of moles. How do we do that? Well, we know that the number of moles N is equal to the mass of a substance divided by its molecular mass. So therefore, the number of moles N is equal to, what's the mass of hydrogen? We're given 4 grams from the question. So we have 4 divided by the molecular mass of hydrogen, H2. Okay, what's the molecular mass of hydrogen? H2 is simply the atomic mass of hydrogen is 1 times 2. So we have 2. So this becomes 4 divided by 2, which gives us 2 moles. So we have converted these 4 grams of hydrogen into number of moles, and it is 2 moles. That is step number one. What does step number two say? So allow me to backtrack a bit and show it to you. Step number two says use the mole ratio from the balanced equation. So let's go ahead and get the mole ratio from the balanced equation. So how do we get the mole ratio? Well, it's simple. To get the mole ratio, we simply check out the question. The mole ratio says calculate the mass of water. So the first thing we are handling is water, H2O. And they say calculate from 4 grams of hydrogen, H2O and hydrogen, H2. Now from the equation, H2O is written as 2H2O and hydrogen is written as 2H2. So the mole ratio becomes 2:2. We simply extracted the coefficients. This is 2 and this is 2. So we can simplify this to become 1:1. So in simple terms, what this is saying is 1 mole of water is produced by 1 mole of hydrogen, H2. So we have extracted the mole ratio. Step number 3 would be to apply the mole ratio to get the number of moles of substances that we're looking for. Now remember that we converted these 4 grams of hydrogen to become 2 moles. So to apply that, what we would simply say is X moles of water will be produced by 2 moles of hydrogen. Remember, we converted these 4 grams to become 2 moles. And the question says calculate the mass of water. Now I know we are saying X moles of water, but now what we are asked to do is calculate the mass of water. So when we use this mole ratio to find the number of moles of water, then we now convert it into mass. So at this point, we cross multiply. So when I cross multiply, I have 1 times x equal to 2 times 1. So therefore, this becomes x equal to 2 moles of water. 2 moles of water. So now I have gotten the number of moles of water that I need. But the question says calculate the mass. So therefore, I have to convert now from moles into mass. And how do I do that? I simply use my mole formula. Remember, number of moles N is equal to the mass divided by the molar mass of a substance. This time I'm looking for the mass. So therefore the mass becomes number of moles times the molar mass. So let's get our answer. So the mass of water will now become the number of moles of water. We calculated it to be 2 moles. So this becomes 2 times the molecular mass of water. What's the molecular mass of water? Water is H2O. So the molecular mass simply becomes the atomic mass of hydrogen is 1. This becomes 1 times 2 because there's a subscript of 2 here. And then plus oxygen has the atomic mass of 16. So altogether we have 2 plus 16. This gives us 18 as the molecular mass, 18 grams per mole. So the mass becomes 2 times 18, which gives us 36 grams of water, H2O. So the answer to that question is the mass of water produced from 4 grams of hydrogen is 36 grams of water. I'm sure you can see how that was done. Simple, easy, and straight to the point. The next question on the screen says, given, we have this equation on the screen, given this, calculate the mass of ammonia produced from 28 grams of nitrogen. So step number 1 would be to convert the mass into moles. So we know that number of moles is equal to the mass of a substance divided by its molar mass. And the mass of nitrogen in this case is 28 grams divided by what's the molar mass of nitrogen? The nitrogen molecule exists as N2. Okay, you can see it from the equation over here, N2. And therefore it means the molecular mass becomes, nitrogen has the atomic mass of 14. This becomes 14 times 2, which gives us 28. So I have 28 divided by 28, which gives me 1 mole. So what this simply means is that I have converted 28 grams of nitrogen to become 1 mole. That's step number 1. Step number 2 would be to get the mole ratio. How do we get the mole ratio? The mole ratio will be gotten from the equation. And the question says calculate the mass of ammonia. So we're dealing with NH3 ammonia and nitrogen N2. And from the equation, NH3 or ammonia is written as 2NH3 and nitrogen is written as N2. So the mole ratio becomes 2:1. What this means is that 2 moles of ammonia NH3 are produced by 1 mole of nitrogen N2. That's the mole ratio. Step number 3 would be to apply the mole ratio to obtain the number of moles of ammonia. So how do we do that? We simply say X moles of ammonia NH3 will be produced by, now we've converted 28 grams of nitrogen to become 1 mole. So we write 1 mole of nitrogen N2. So we cross multiply, and when we cross multiply, this gives us X multiplied by 1 equal to 2 times 1. So therefore X basically is equal to 2 moles. 2 moles of ammonia NH3. So the number of moles of ammonia produced is 2. But we're not done. The question says calculate the mass. Calculate the mass. So step number 4 would be to convert number of moles into mass. And we know that the mass of a substance is equal to the number of moles multiplied by its molecular mass. So let's go ahead and apply this to get the answer. The number of moles of nitrogen was calculated to be 2 multiplied by what's the molecular mass of ammonia. So ammonia is NH3. Okay, the molecular mass becomes 14 plus hydrogen over here is 1 multiplied by the subscript of 3. 1 times 3. So basically we have 14 plus 3, which gives us 17. So therefore we have 2 multiplied by 17, N times molar mass. So we have 34 grams. So the answer to that question is 34 grams of ammonia are produced, or yes, 34 grams of ammonia are produced from 28 grams of nitrogen. 34 grams of ammonia produced from 28 grams of nitrogen. Let's handle yet another question. Given this equation on the screen right now, calculate the mass of magnesium oxide produced from 48 grams of magnesium. Well, step number 1, we convert. Step number 1, we convert the mass into number of moles. So can you see how this is being done? Everything is being taken back to the mole. The mole is so important because that's what serves as your map to the right answer. So we have 48 grams of magnesium. The number of moles will be equal to the mass divided by the molecular mass. The mass of magnesium is 48. This becomes divided by what's the molecular mass of magnesium. Magnesium exists as a monoatomic molecule, and the atomic mass of magnesium is 24. So we have 48 divided by 24, which gives us 2 moles. So what this means is that we've converted these 48 grams of magnesium to become 2 moles. Step number 2 would be to obtain the mole ratio from the chemical equation. So how do we get the mole ratio? It's quite easy. From the question they said calculate the mass of magnesium oxide. So we have magnesium oxide and we have magnesium. So we're dealing with magnesium oxide and we're dealing with magnesium. From the equation, we can see that magnesium oxide was written as 2 MgO and magnesium was written as 2 Mg. So basically, this becomes 2:2 because each has a coefficient of 2 in front of it. Simplifying this, we have 1:1. What this means is that 1 mole of magnesium oxide is produced by 1 mole of magnesium. So that's the mole ratio. The next thing to do would be to apply that mole ratio to get the number of moles of magnesium oxide. and convert that into the mass. So therefore, under this we'll write X moles of magnesium oxide, MgO, will be produced by 2 moles of magnesium. How do we get these 2 moles? Remember, we've converted 48 grams of magnesium to become 2 moles. That 2 moles is what is here. So let's cross multiply. When we cross multiply, we have X times 1 equal to 2 times 1. So X is basically equal to 2 moles. So we've calculated the answer, or the number of moles, for magnesium oxide to be 2 moles. 2 moles of magnesium oxide. So the next thing to do would be to convert the number of moles back into mass. And we know that mass of a substance is equal to the number of moles times the molecular mass. Number of moles for magnesium oxide, we calculated it to be 2. So this becomes 2 times magnesium oxide. Let's get the molecular mass. So this is 24 plus 16. Now the atomic mass of oxygen is 16. That's why we have 16. And for magnesium, the atomic mass is 24. 24 plus 16 gives us 40. So we have 2 times 40. And this gives us 80 grams of magnesium oxide, MgO. I'm sure you're seeing how this is playing out. So the mass of magnesium oxide produced is 80 grams. Pretty easy, pretty simple, straight to the point. Well, the next example on the screen says, given this equation, you can see the equation over here. Calculate the mass of carbon dioxide produced when 32 grams of methane is CH4, reacts completely. So step number 1 would be to convert this mass, 32 grams, into number of moles. Okay, so to convert into number of moles, we know that N is equal to the mass of a substance divided by its molecular mass. Now, what's the mass of methane? It's 32 grams divided by, what's the molecular mass of methane? Let's calculate it. CH4 ends up giving us, the atomic mass of carbon is 12, and we have 12 plus, the atomic mass of hydrogen is 1. 1 times the number of the subscript, which is 4, the number of atoms. So we have 12 plus 4, which is 16. So we have 32 divided by 16, which is 2 moles. So what this simply means is that we've converted this 32 grams of methane to become 2 moles of methane. That's step number 1. Step number 2 would be to get or obtain the mole ratio from the chemical equation. So let's get the mole ratio. How do we do that? Well, the mole ratio will be gotten when we know what we're focusing on. This question says calculate the mass of carbon dioxide. So the first thing we're focusing on is carbon dioxide, CO2, produced when 32 grams of methane. So we have CO2 and CH4. Now from the equation, CO2 is written plainly as CO2. You can see it over here. And methane, CH4, is written plainly as CH4. So the mole ratio becomes 1:1 because the coefficients in front of them are 1 each. So what this simply means is 1 mole of CO2 is produced by 1 mole of CH4 or methane. So now that we've written that out, it's time to now apply that mole ratio to get the number of moles of carbon dioxide. So we write X moles of CO2 or carbon dioxide will now be produced by, instead of writing 32 grams now, I've converted it into number of moles. So we have, will be produced by 2 moles of CH4, methane. So at this point, I can cross multiply. So when I do, this leaves me with X times 1, okay, is equal to 2 times 1. So X is basically equal to 2 moles. So what that means is that the number of moles of carbon dioxide produced is 2. So let's convert that into grams so we can get the mass of carbon dioxide. And we know that mass is equal to the number of moles times the molecular mass. The number of moles is 2. So the molecular mass of carbon dioxide, CO2, let's calculate that. Carbon has the atomic mass of 12. This is plus. Oxygen has the atomic mass of 16. This is times 2. We have a subscript of 2. So this is 12 plus 32. This gives me 44 grams per mole. That's the molecular mass. So we have 2 times 44, which gives me 88 grams. So the meaning of that is the final answer is that says calculate the mass of carbon dioxide. It is 88 grams. That's the answer to the question. I'm sure you saw how all these steps were applied in getting the answers to this question. So here's a brief snippet into an exam strategy that you can use. When you're solving stoichiometry questions in examinations, first of all, you write the balanced equation. Secondly, you calculate the molecular mass values. Thirdly, you convert that mass into moles. Then fourthly, you use the mole ratio. And then lastly, you convert into mass. That was exactly what we did in the rundown of steps that we used to answer the examples that you saw previously. So a quick summary is mass to mass calculations use the mole concept. You saw how we applied the mole concept. The balanced equation always provides the mole ratio. So first, always convert mass into moles, use the mole ratio, and convert back into the mass at the end of the journey. So here are some practice questions I'd like you to try out your hands on and drop the answers in the comment section where I'd be waiting to receive them. So here's the first one on the screen. Here are some more practice questions for you to answer. Go ahead, pause the video if you need to, write down the practice questions, answer them, and drop your findings in the comment section, and I'll be waiting to receive each and every one of them. We have another one on the screen right now. We have yet another one on the screen right now. Feel free to pause the video and check out and write them down if you need to. Get your answers and drop them in the comment section where I'll be waiting to receive them. And finally, or next up, we're going to be having the topic that deals with something called the limiting reagents. I trust it's something you're going to enjoy superbly. In the meantime, go ahead, like, share, and subscribe to this YouTube channel, and I'll see you in the next video. Stay blessed.